Hi everyone, Oskar Świerat here. Welcome to part 4 of the tutorial series about graphics profiling in Unreal Engine 4. Throughout the series, I have explained various methods of measuring performance, ranging from the very basic ones, like the console command ~stat unit graph. Then in part 2, I have explained what is the pipeline on the GPU and how to adjust your content to maximize potential performance. Now, in part 3.1, I showed a tool that is called GPU Visualizer, and it shows us the breakdown of the scene into particular rendering passes. For example, pre-pass, base pass, pass of lighting. And in part 3.2, which I highly recommend, I explain almost every one of these passes. This tool is advanced, it's very good, but it doesn't show us everything. In particular, when you, for example, expand the base pass, you can only see the category of dynamic meshes and of static meshes. And the same in lighting. This tool is very good, but it has its limitations. That's why in this part 4, I will show you an external profiler. This was a built-in profiler, and this tool is an external profiler, a separate application made by Intel. And here you can see not only specific passes and how much time did they take, even if still you have this information. Here you can see base pass, translucency, and so on. But also you have the ability, really priceless ability, to click on a particular set of draw calls. So I will go into the detail later, but basically the bigger the block on the graph on the top, the bigger the amount of time it took to render this particular set of draw calls. For example, this part of the landscape. So this tool gives us amazingly detailed insight into what's happening in our frame. Even the cost is explained in microseconds instead of milliseconds. So 1,000 here means 1 millisecond. In the case of this scene, I made everything to make the base pass be the biggest cost. Usually base pass took like 3 milliseconds maximum. Here it took 9.5 milliseconds. Because intentionally I have done a very complicated shader, even if it doesn't look like that. Yeah, I know. It looks like a game from 2000 or 2003. Still, this shader is complicated when it comes to computations. Not only it has a lot of nodes, but these nodes are nodes like noise, which takes like 80 instructions per level. In total, this shader is taking 413 instructions in the base pass. If I press tilde and enter stat GPU, I can see that the base pass, from my camera, is taking on average 4.6 milliseconds in that resolution. Now, if I change the scene to this one, where the landscape is very simple, you can see the base pass taking 0.7 milliseconds. So it's definitely the case. Okay, here I have less asteroids, because they are also, as I explained in part 3.2, the amount of geometry also affects the base pass. But let me show you this example. The same amount of geometry, simple shader on the terrain, on the landscape, and the base pass is taking 2.6 milliseconds. So still a twofold improvement. So this Intel tool I will show you in this video, it's called Intel Graphics Frame Analyzer. This is a part of a bigger toolkit, but we will focus on the tool to capture a frame and this Graphics Frame Analyzer. Basically, it's not only a profiler, it's also a graphics debugger. So here you can find the textures that were being used to draw the scene. You can also view the geometry that was used to render this thing. There is also a surprising fact when it comes to this software, but I will share it in the end of this video. And now let's proceed with the tool. How do we run it? Because okay, here I have opened the scene, I was well prepared, but let's assume we start from scratch, we have nothing. Let's go back to the desktop. So to run the tool from Intel on our scene, we have to build the game into an executable. It's an external tool, so we'll have to package our game. Okay, this is my project. I also included a blueprint that switches the current level we are on, because I want to test both the heavy scene and the light scene. A quick reminder that this project was used throughout this entire series. There is also a bonus map that shows you the volumetric lighting and how it performs, so much recommended. You can download this whole project from my Gumroad page. So it is gumroad.com/techartaid, and here you can download the project. If you don't want to do a donation, you can enter a price of 0 and just press buy this. And as for the Intel tool, go to software.intel.com/en-us/GPA. You can find all these links in the description of the video. The software is free, this is the only required step. So back to Unreal, I go to File, Package Project, and package it for Windows 64-bit. Okay. It will take a while, especially if this is the first time you are doing packaging of the project. And it has completed successfully. So I can now close Unreal, go to my project, and there is my exe file with the icon of Unreal Engine. Now, I run the software called Graphics Monitor from Intel. It is docked here in the bottom right corner. I right click it and click Analyze Application. This window pops up. I can select my application. Okay. And press Run. So this is our build game. It's running in full resolution. Now Ctrl F1 shows us more metrics, and again it shows us some tooltips, but basically we won't be using these shortcuts. We'll just capture a frame and do everything from inside the frame analyzer. So under keys 1, 2, 3, 4, 5, I have scene selector, so I press 3 and go to this heavy base pass scene. Again, pressing tilde and entering stat GPU, enter, will provide us with this information. Here I can see the base pass is taking 8.5 milliseconds. Now, before we capture the frame, I have to press tilde and enter toggle draw events as a single word. Toggle draw events, and after I do it, I will have to capture a frame quickly. Basically, it adds more information to the rendered scene on the GPU, but it comes with a cost. So I press enter. I see that my frames per second are dropping, but you shouldn't worry about this, because the measured data in the frame analyzer will be correct. Only here we can see the FPS dropping, but in the frame analyzer it will be fine. So, to capture a frame, I press Ctrl-Shift-C. Ctrl-Shift-C. Okay, capture complete. I can toggle draw events again. So basically turning it off. FPS is back to 64. So in level, under the shortcut 4, the landscape is simpler, and under the shortcut 5 I have even less geometry. So I can toggle draw events again and press Ctrl-Shift-C. Okay, this scene is captured. I quit the game, Alt F4, and now I can open the frame analyzer. Here you can see the frames I captured, the entire history. So here is the newest one. So what do we got here? The graph on the top here, it is showing the draw calls as they happened, as they were issued by the engine. So here you have the draw call number 0. Here you have the first 184 draw calls, and the total amount of them was 292. Now, in the upper right corner, I can set what each of the axes mean. So this will still be the number of draw calls, the number of the current draw call, but I can set that the length on the axis is, for example, duration it took on the GPU to render this draw call. That is why you can see this thing being much more longer, 180 to 184, just 4 draw calls take so much time, while here, for example, 8 draw calls take only this much time. I hope it is clear, but I can just set to constant, and now you see constant information only with the duration set on the y-axis. Usually I set both axes to GPU duration, but you can do differently. For example, you want to know how much vertices were issued to render each draw call, each set of draw calls. So here you can set vertex count, and as you can see, sometimes the vertex information doesn't matter. For example, it can be post-processing or something like that, while quite quick draw calls can use a very high number of vertices. You can also do pixels rendered. So this is the amount of pixels it took on the screen. For example, this thing. This is this part of the landscape. And the thing here is probably post-processing because it is taking the maximum number of pixels. This small thing here is this patch of the landscape. Okay, I will return to GPU duration here. I forgot to mention, but maybe it is obvious now, that by clicking on the graph, you highlight the particular set of draw calls. And here is the list. As we expand it, because we use toggle draw calls command, we have the names attached to draw calls. So for example, this is the base pass, and this is a part of the base pass under the number 193. The type was draw indexed instanced because these are the GPU instances from my instancing tutorial for Unreal. This particular part had 360,000 of primitives, triangles, and it took 0.4 millisecond to render this patch. I can use Shift or Control to select particular ones, exactly like you will do in File Explorer, for example. So these things I selected here are highlighted on the bottom. If you are wondering what the pass, render velocities, base pass, begin occlusion tests and so on, what it exactly means, then I recommend the video Graphics Profiling Part 3.2, where I explain every one of these passes. When you need this information in detail and easier to browse than just a video, then I will be doing a book. It will be available on my Gumroad page. It will be an ebook containing all the information from this tutorial series about profiling and some more information, some more details, especially links to interesting sources and the details that were just too much for the video, because still these videos were quite long. So if you want to get notified about this book when I release it, you can provide your email here and just click follow. When you download the project, you are also automatically subscribed to the newsletter, so you will get this information too when the book is released. Now the very important thing about this tool from Intel that makes the whole difference is that you can not only see the particular meshes that took the amount of time you can see here, but you can also find lights. This is something that is not possible from within Unreal, but is tremendously useful, that you can just expand the list here, go to lights, direct lighting, and even in non-shadowed lights, you can select the ones that took the most time to render, and you can see their area of influence. Okay, this lamp was hitting the entire scene, but maybe this one. I do it with the tick box on the left of the name of the draw call, or the number if we don't have a name attached. So for example, this is the area of influence of the lamp I selected. It took not so much time to render because it is small, but for example this took longer, and when I press it, I can see it covered a much bigger area. So you can pinpoint the frame cost down to a single light, even if it is light in deferred mode. Now with shadowed lights we have even better situation, because we can see the name of each light. The first part is obviously the name of the level, and then the name exactly as you have it in the editor. So let me select the Spotlight 3 and Spotlight 4, the two heaviest shadowed lights, and you can see the cone of the spotlights. Now I think the rest of the tool is pretty self-explanatory. Please be sure to check out the tabs you see here, especially texture and geometry. It has very interesting information that is useful not only for debugging and profiling, but also to learning about how stuff works, how the engine works, what kind of textures and buffers are stored. And before we end with this video and this series, because this is the last part in this series, I want to show you three things. One thing is the alternative to Intel. If you for some reason don't want and can't use this tool, there is also an open source debugger, RenderDoc. It's less of a profiler and more of a debugger, but still a quite similar tool. If you want to check duration of a pass, you can find it here. And another alternative is GPU Perf Studio from AMD. And it looks like that. So as you can see, the idea behind this software is quite similar. This is a tutorial from Intel. It's called Unreal Engine 4 Optimization Tutorial. I really like this tutorial. It's in a text form. but it explains many concepts really well. For example, the relation of milliseconds to frames per second, the importance of why we should measure in milliseconds. Now the next thing is the post on Twitter by Ikrima. I'm really thankful for this particular post. Basically, the number of views really jumped up after this, so thank you very much. The response to this was very good. And the last thing I want to show you is the one I promised when I started showing the intro tutorial. The one thing that's interesting, but not quite expected. When I run the graphics monitor, here I selected my build of the game, but I can select any game. Basically any 3D game can be loaded here. So for example here, I have the latest hit, Prey, from Arcane Studios. Let me run it. And you can see our familiar Intel capture software in the left upper corner. So it works exactly like it did in Unreal. So you can imagine what it means. I start the game like I normally would. GPU duration is actually turned off because I forgot to close the frame analyzer. If you're into intelligent sci-fi games, then I really recommend Prey. If I wasn't doing this tutorial, I would be playing Prey. I even took a break from the amazing Fire Emblem Awakening on my 3DS just before the end of the game, because I was so intrigued with this title. Okay. Thank you for the tooltip. Before I die, I press Ctrl-Shift-C. And guess what happens? I quit the game. And guess what I have here? This is the capture from our game, from the game Prey. That is not a screenshot, it's a full scene capture with all the render targets and all the geometry. We can do exactly the same stuff we did with our Unreal build. Let me find some geometry. Okay, so I have to admit I find it really fascinating. Of course, I hope you will use it for the good causes, like learning about how particular game is rendered. The same thing Adrian Kuresh is doing on his blog with the amazing write-ups on GTA 5, Doom and so on. But you can extract the exact geometry used in the game. If I select more of them, but not too much because it will hang, just some of them. Okay, here I have my textures. The very textures used within the game, with all the geometry for us to browse. Okay, I hope you got interested in this software. Again, you can download it for free from the Intel site. If you don't like it, you can try a RenderDoc or AMD alternative. If you haven't already, I recommend watching this entire series. Unless of course you know this stuff, but still I think many good details can be found here, especially in the all categories stats guide video, when I explain the categories that really sometimes can't be found in documentation. Thank you very much for staying with me throughout this entire series, and see you next time. Cheers!